Thank you everyone for being here, both the in-person audience and also the online audience. This is the paper session on smart homes and buildings, and we'll be having presentations from the domOS project, the ESHER project, and also a paper presentation from a representative from the KIT Institute in Germany. Here you can see the agenda. First, we will hear from Dominique Gabioud, sorry if I'm pronouncing it wrong, from the University of Applied Sciences of Western Switzerland in representation of the domOS project. The topic is Decoupling Infrastructure and Services in Smart Buildings, the domOS approach. Later on, we will hear from Niall Buckley from EIS regarding the ESHER project on enabling smart home energy responses. And finally, we will hear from Tristan Emich from the Karlsruhe Institute of Technology regarding smart readiness indicators as an interactive tool. And then we will have some Q&A space between each session, but also at the end, if you want to discuss any topic, we will also leave some time. So now, without further ado, I will welcome Dominique to the stage to present the domOS project. In a second, I'll put your presentation there. So here. Yeah, go ahead, Dominique.
So, hello everybody, welcome to my presentation. My name is Dominique Gabioud. I am a professor at the Swiss University of Applied Sciences, and I'm also coordinating the project domOS. So we are going today with you to speak about smart building. But I mean, you have basically most of the project. They present very nice services, where you have more flexibility, more efficiency, advanced control, and everything. These are very nice things. But at the end of the day, you have to deploy this in buildings. Most buildings are not new buildings. They exist. They have been built tens of years ago. They have an existing infrastructure, and what you have to do is you have to have an efficient way to deploy the services, because deploying services requires money, and so it's really important that deployment can be streamlined. Okay. And my presentation and the work of our project is to find a way to streamline the deployment of services in existing buildings. Well, here you see some word about the domOS project. Maybe just one point is that we are almost at the end of the project. It will be finished in February 24. Well, what happens in smart building today? I mean, digitalization is progressing everywhere and is also progressing in smart building, but it's progressing in a scattered or uncoordinated way. What we have is that when you buy a solar inverter and solar panels, you get the solar apps. When you buy the EV charger for your EV vehicle, you get the EV apps. And when you have something to control the blades, then you have a totally different system, and you end up with parallel silo solutions. And also these solutions, they are all very nice, but they are all different. And if you think about energy management in a building, this is not a silo application. This needs coordination. You have to charge your car when there is PV production, and then when it is very warm, you have to close your blinds and all that scenario here. Okay. And also you need many services and many services use more than one appliance. For example, if you want to have an energy dashboard for your house, you need to talk with your heat pump, with your PV inverter, and so on. No? Okay. This is what I said before. We have silo solutions in building where we have an appliance, some platform mostly operated by the manufacturer of the appliance and some applications. And at least an integrated approach exists, but this is rather for a big building where there is a building automation system that has been designed at construction or deep renovation time of the big building. But in small buildings, it's a very scattered systems that we have. Okay. What we notice is that there is a lack of integration. As a building occupants, I would like to have an integrated approach and not parallel solutions. When I have 2 of them or 3 of them, this is okay, but maybe if I end up with 10 solutions, then it becomes really difficult. And also, the deployment of cross-product or cross-service solution is pointlessly cumbersome. Huh? If I want to control my heat pump according to the PV production, what is done basically, the heat pump manufacturer gives me a meter and I put it right next to the meter of the PV inverter, so I have 2 meters, and one to discuss with the heat pump and one to discuss with the PV inverter. This is the situation. Huh? Okay. So, what we tried to do in our project, we tried to decouple application from appliance model. So we wanted to have an application that controls heat pumps, whatever the brand and the type of the heat pump is. If you think, when you have what happens in the computer world, I mean, I'm a rather old guy, and when I was young, I had to program let's say in a drawing program, I had to configure the exact type of the printers that I had to use in my drawing program. Nowadays, very well, you just have your drawing program or your PowerPoint or whatever, and you say print and it works. So it means that printing is decoupled from applications that need printing. But if you are in the energy, in the smart building domain, nowadays it's not the case. And what we wanted to do is something very similar. Okay? And also, what we wanted is that the uniform access to appliance is one thing, but it's not enough. What we wanted is that a service can somehow discover the building in an automated way. What kind of heating system, what is the size of the building, how is domestic hot water produced, do we have district heating or heat pump, is that an electrical heat pump, what kind? So, because this is important for a service. So we wanted to let applications, maybe what we say is that, for a service to work, we need the coordination of an application and the field infrastructure. Both together make the service. And for this, to make it very simple, we have the in-building infrastructure and some application. And both allow us to deploy the service. So what we want is an application needs to understand the building and not only to have a uniform access to appliances. So basically what we did, we made a kind of mediating layer. On this mediating layer, you can, well, I know this is a little bit oversimplification and it's not as simple as that, but you can hook any appliance with some connectivity, and you can also hook any application. Okay? How we do it? To personalize these mediating layers, we need two types of document, of machine-readable document. We need a building description document. Sometimes this is the index.html of the building. Imagine that if for a building you have a home page, so this is a home page of the buildings. And what we have also, we have for each connected appliance, we have a machine-readable description document that explains how to connect with that device. Okay, and the mediation platform is universal, is unique, and is just personalized by building description document and by appliance-specific document. So what domOS is and what it is not, it's a specification and not a framework. So with the specification or with the reference model, you can implement it in multiple environments. And it's not a frame, there is not something like a domOS framework where with some licensing model, even open source, but we have upgraded 3 existing platforms to that model. So what we need, this is our 2 objectives. The first one is to decouple application from appliance models. So this is not a building specific issue. I mean, there are a lot of cases where applications needs to address multiple models of the same type of device or appliances. And for this, we didn't define our new standard. We base ourselves on an existing standard promoted by World Wide Web Consortium. This is the standard, or it's called Web of Things. Actually, Web of Things is collections of standards promoted by V3C. And for the index.html, so we define our own ontology. Ontology is like a vocabulary or a language. And this is a domOS common ontology that we abbreviate DCO. So this is our language for defining what we have in the building. And in the DCO, we reuse existing ontologies and complete them where needed. Existing ontology, maybe you have heard of Saref or Saref for inner, we reuse them. And of course, these 2 things, they are somehow linked together. I will explain later how. So a very, very simple few words about Web of Things. Any application, anything or appliance or device, VOT name, use the word thing, is represented as a collection of properties that an application can read or write of actions that can be executed and events that can be subscribed. So this is how every appliance and device in the house is defined as a collection of properties, actions, and events. And what we have in the VOT, we can have for each appliance a specific document called the thing description that maps the standard interface, the standard API, which is called VOT scripting API, with the messages exchanged with a real device. So when you are on this side, you read and write properties, you execute actions, you subscribe to events, and you get callbacks when an event happens. Okay, you don't care whether it's Modbus, BACnet, MQTT, HTTP, HTTP, or whatever. Okay, and for this, what you need is just a document indicating how the mapping is done for a device. So really, this is important to understand. We do not ask to upgrade an appliance or to be compliant with some specification. We, through a formal description of the interface to a device, we adapt to what exists with the device. Okay, how to craft TDs for appliance? Well, maybe first a thing description specify not a model of a heat pump, but a given heat pump in a given control room of a given building. But you can make model-specific documents. This is called things model. And then you can translate a thing model into a thing description by specifying, for example, an IP address or whatever, or something specific to an instance. And as of today, if you want to use domOS, you have to craft yourself the things model for your heat pump or your solar inverter. But the vision is that in the midterm, manufacturers will provide things model for their devices. Well, we have a project with a Swiss association that has already started such an initiative. They get in touch with the manufacturer of a heat pump, of a heavy charging vehicle, so that they make a things model-like document. We still have to see whether they want to have a specific document or if they want to take the VOT format. But basically, this is the same approach. So the idea is that, let's say, in a couple of years, if everything goes well, you buy an equipment, you go to some repository, you download the driver, and then in your program, you can readily see the appliance as a collection of action properties and events. So what about the domOS common ontology, the DCO? Well, first, let me state that the DCO has really been came from the 5 demonstrators that we have in our project. We have very different demonstrators, and we tried to find a language that was appropriate to define all the buildings that we had in our demonstrators. And also, the DCO is a living ontology. It's an evolving ontology, and we can adapt it to a new situation or to new needs that could arrive. So what we have, we define the building environment, we define building metadata, we can define the energy flows in the building, and we can also define what can be measured and controlled in the building. So this is where we define, we have a link with things descriptions, and I will come up to this, how these links are organized. Well, also that we try to put as few requirements as possible on deployment. You can have the domOS architecture implemented on a Raspberry Pi and have everything local. You can have also your you can have all the things description and the building descriptions hosted in the cloud. You can have things description document that do not point to Modbus register in the heat pump, but to some HTTPS URL provided by an existing IoT platform. So we have really a lot, and in our demonstrators we have very different deployment architecture, and this was also a focus of us not to constrain the deployment, because we understand that the situations are very different. So this is where our demonstrators are. So we have two demonstrators related to electricity. What the services are, this I will say a few words on the next slide. We have one demonstrator related to district heating, and two demonstrators where we optimize the generation and distribution of the heat inside the building in Skive, Denmark, and in Neuchâtel. And the services that we have, we separate them in 5 categories. We have services related to energy flexibility. We use the energy flexibility of a heat pump for market services for electricity market, but we also use it for peak shaving for district heating. In Aalborg, this has some relevance because when they need a lot of heat, they have to turn on the coal power plants for peaks, so they want to avoid peaks and avoid using coal. And also sometimes we use it for maximization of self-consumption in case of PV production. We have closed-loop control for energy efficiency. Here, the goal of the service is to lower the temperature in the distribution network, is a internal heat distribution network. That way we have less losses, because loss depends, the higher the temperature, the more loss. And also the efficiency of the heat pump is bigger because you have to heat at a lower the difference between the cool coolant and the heated coolant is smaller. We have prosumer empowerment, dashboard services, and we have even a warning service based on detection of behavior detection, deviation for elderly people. Basically, we measure electrical consumption of devices like fridge and heating plates, or how do you call them? cooking plates, and then we try to derive behavior change and raise alarm if there are changes. So this is very experimental service up to now. But you see that based on this architecture, we can deploy a large spectrum of services, and we have also several services using the same endpoints, the same monitoring and monitoring point in the building. So that's all for my presentation. Thank you for your attention.
Thank you very much. Are there any questions here in the room? Yes, Niall?
Yeah, it's a really good presentation. I like the description of the architecture. It's easier to follow. Just out of curiosity, if I'm a participant in the project and I want to hook up to the domOS system with the equipment I have in my home, from the front end, what do I have to do to hook everything up? How does it work?
Okay, so first you have to identify what kind of data interface you have to your device. If there is, let's assume there is a digital link, some digital link, okay? Then you have to craft a sync description for that equipment, no? According to the VOT format template. Then you take a VOT compliant library like SyncWeb, for example, and then this library you can in this library you have API to read the sync description, and then readily the library create object for all properties, event, and actions, and you use this object readily. And then if you want to go one step, so this is really for appliance independent, I mean, to see your appliance as collections of these objects. And then if you want to go one step further, then you would need to craft a building description saying that this is a heat pump of type XYZ that heats my building's envelope and my domestic hot water, and that at this event is the instantaneous power consumption of the heat pump. This event let me assign the reference temperature for the boiler, and so on and so on.
Thank you. Are there any other questions? Okay. Thank you very much, Dominique. So now we go to the next presentation on the ESHER project. And I welcome Niall to the stage. You can go ahead.
Perfect. Thanks very much. So this will be a reasonably brief presentation about the ESHER project, which is a local Irish project sponsored by the SEAI, which is the Irish Agency for Energy, essentially. And an IES, we're a climate tech company that works with, for people who aren't familiar, who work specifically with buildings, but we also branch out to city scale and parks, and anything that we can create a digital twin of, we create one and get involved with various companies. But with this project, this is social housing, new developed social housing, making it smart for the occupants to, I suppose, best utilize their smart technologies that they have in their home, that they're not really aware of or not sure how to, I suppose, exploit to the best of their advantage. So this is basically what I'm going to go through. So I'm just going to skip this slide because you're going to see each slide anyway. But just to mention the other partners, TU Dublin is our university partner. They're obviously based in Dublin. And O'Callaghan is a low-cost social housing NGO, I guess. I think that's the best way to describe them. And so they help with building much needed social housing in the Republic of Ireland. So this is, I think, a nice slide to describe the goal of the project in general. So this is based on a single parent staying at home with 2 kids. The common, or one of the personas that we identified in the social housing. And this is their uncontrolled load profile. And this is their controlled load profile, or flexible load profile. It's where we give them, I suppose, clues to use their energy much more efficiently. And so the buildings are, and I'll go through them, but they have PV power, so PV panels. And what we're trying to do is make sure that the occupants are making the most of those PV panels. So above is just the spread of using energy unconsciously, just when they need it. And below is when they're being prompted and told, this is the best time to use it. And I think what's most interesting, and I'll at the end describe peer-to-peer trading, is the charge that we get out of the battery that was put in this place. So there's a few batteries put into these buildings. So at the end of the project, or in this presentation, I'll go through some P2P stuff at a very top level. But that was this is a sandbox virtual test of a peer-to-peer, because we have all the data. So if we had the right infrastructure for trading on the national grid, we could theoretically put this together with these buildings. So the build context, I think it's best to describe pilot site. So it's about 10 or 20 buildings, 20 to be precise, but 10 I think was the ones we're looking at. And essentially they are based in an area of Dublin that is lower socioeconomic background. The area was originally tower blocks that you would see in the likes of London or in Eastern Europe, big concrete 10, 20-story buildings that were dismantled, and the occupants were put into single-family homes around the area that's better planned. So these are A-rated homes. I think one thing that's interesting to draw on is that part of this project, because of the costs, they have to choose between PV panels or heat pumps, but not both. So the ones we're looking at have PV, but they also have gas-fired central heating, which is a bit strange for new houses, but that's just the situation we have. So originally the project started at the start of COVID, so it wasn't ideal. But we managed to make it work within reason from remotely starting the project and then getting some interaction with the occupants. But initially there was a big scope to put out smart plugs and various IoT infrastructure to really understand profiles and how equipment's being used. But essentially we have to reduce it down to a bit more less equipment, because it was too disruptive for the occupants. We couldn't have enough time with them to describe what the benefits are, and it was a bit too disruptive to their day-to-day events. So we have to go with some basic technology. So the Cubino smart meters is what was installed, because they were nice and flush and not noticeable, so they just went straight into the board. So this was pretty handy for PV and for the mains for the actual building. And then Samsung Smart Things was used instead of Raspberry Pi, because at the time we all know there was a semiconductor shortage and Raspberry Pis were very difficult to come by. So went for standard case, like off the shelf kind of equipment rather than stuff that we could customize yourself. So with the equipment in, this is a profile of the building I was describing. And in blue, we have the mains power. And in blue, we have the solar power, and in green, we have the mains power. So we can see in the profile here that the user, in this case, is using stuff generally in the morning and then in the afternoon, where we generally tend to see peaks. And this is related to school, I think, and just their profile, taking care of their kids. And you can see there's a good bit of activity that happens as well outside of the peaks, but what we want to do is try and make this a bit more smooth. So that's the actual recorded data that we have. Then we build a physics-based digital twin that most of us will be aware of, which is essentially, this one's derived from paperwork from the manufacturers or the developers who built the buildings, because we couldn't get on-site surveys, again, because of COVID. So we built a fairly accurate digital twin based off all the files that we got from the developers. And then we calibrated this with the actual real-world data. So it was reasonably accurate to make predictions on how that building was going to perform in a calendar year. So here's our predicted models. On the left, predicted electricity consumption, and then PV generation on the right. So with these predicted models, we could then start optimizing and finding out when is the best time for to use energy, essentially, or to shift the loads to optimize not only energy to get it off the peak demands, but also to reduce costs for the actual occupant. So the solid red line was the original profile. The dotted red line is essentially where we're saying to optimize your energy use or where you should shift your loads. And then the blue line is just the cost based on peak demand. So part of this, we needed to get the occupants, we needed to communicate with the occupants in order to tell them when to shift their loads or when to change their behavior. So our UX team did some desktop surveys with the occupants. Not face-to-face, but and essentially created a non-expert or a somewhat simplified dashboard for people to understand. And at the bottom, this is theoretical, but this is the energy trading platform that we're testing on the back of it. So it's very hard to see there, but basically every 5 minutes it says whether you traded energy or whether you bought energy. So, but yeah, this is the platform we use with the occupants to get them to basically alert them to how their energy is being used. Yeah, I've kind of described most of this before, so I'm going to skip through the text. So this is the interesting part. We built personas based on, or profiles based on the building occupants. So this is the single parent with the 2 kids that I described below. This is a kind of a user experience a survey done by our UX team, but it builds a profile based on what their optimal goals are in their building. And it's hard to see with the yellow notes, but it's about interactions with your kids, leaving lights on to keep them comfortable at night, watching TV while doing the ironing, different behaviors and patterns of using energy that could be shifted, or we could find space for them to be shifted. And the overall goal of this occupant was financial benefits. So they wanted to get money back from their PV panels. So one of the best ways, or a new novel way of optimizing PV use or renewables on site is a new concept called peer-to-peer trading, where not only would you, at the moment you would trade energy back with the grid if that's what's enabled by your local DSO, but if you're on a part of the grid and it's enabled where you can actually trade with your neighbors, then you can set up a blockchain platform that enables you to trade with your local community. So depending on what part of the grid or the grid architecture and whether it's enabled, you can start trading energy with neighbors, essentially. And with this test that we put was best describing it is essentially I guess it's a branch of the grid where all the neighbors have different personas, and the equations are set for buying low and selling high, but it would interact with the flux of your other neighbors. And what I mean by that is, if I stay at home and work all day, and 4 doors down, that person works on a farm all day, and they're not at home, then their PV panels are generating electricity going nowhere, and I'm using all mine and more. So instead of spending money on the national grid and buying energy at like 50 cents a kilowatt or a unit, my neighbor might undercut the actual provider and say, all day it's 25 cents to buy off me essentially. So and you don't have to do anything, it's automated. Your persona is already set up. So you'll just start buying from neighbors who are selling under the market value. And the idea of this is essentially to encourage people to use their renewables as much as possible through an automated process of trying to find the cleanest energy closest to the house, rather than going back and forth to the national grid. And this creates a really efficient system, which has been tested in other projects, and it shows that it can put peak energy troughs by about 50% in some cases. So it seems to be a very effective tool for demand response, but also for encouraging renewable use on the local site and financial benefits for the actual users. So, and that's pretty much everything I described. It's about essentially getting using the most out of renewables on the local scale without impacting the national grid and its frequency essentially. So the next steps is essentially to see how the dashboards work with some of the occupants, get their feedback, whether they like it or not, whether it's actually having an impact on their energy use. And we just have some outstanding software integration to do, which is just currently happening at the moment. And then when the full year of energy is done, we'll be able to test or have a look at the results of our virtual peer-to-peer trading to see if, in theory, these people were part of this P2P system and it worked, would it have a positive cost benefit essentially. So that's it from the ESHER project. So thank you.
Thank you. Are there any questions?
I just wanted to ask something. At some point you mentioned that early homes, if they could either solar PV or heat pumps, why not both?
I think it was costs, because it's not, so it's so the policy is that you have to go one or the other, I think, but this is social housing, so it's done at a limited cost. Yeah. So they didn't give them the luxury of two, unfortunately. Yeah.
Is the trading platform you mentioned, it's your platform or is it open source?
It's well, that one will be, I guess it'll be open source. I think so. I haven't actually looked at the contract with the SAI, and I think it's the university that's developing it. And what I've seen is it's not that it's not difficult to do. It's just something that can be done open source if you want to do it. But the university, the people, the professor that's working on it might have a predefined intellectual property disclosure thing. So if they develop it and they like it, they might, I don't know, they get to keep it. But yeah, you just take blockchain and you can take some principles and smart meter, and you just take all the trades or the energy exchange, and then you just link it up with blockchain. I know I'm making that sound really easy, but reasonably it's not overly difficult as well. So,
any other questions? I have one.
Yeah.
You said you're going to test this peer-to-peer trading virtually. Are they to test like how would be the benefits for those occupants? Are they going to see those results as part of the engagement strategy? Yeah.
So we have to be, excuse me, we have to be kind of careful. So one of our biggest issues we found so far, I think, with P2P. So the theoretically it's not difficult to put together, but what tends to be difficult is convincing your DSO that this is something worthwhile, because the infrastructure on the grid, it needs stabilizers if it's big scale. So we have another project of 500 buildings on an island in the west of Ireland, and we're not allowed fully develop the P2P network because we need a big stabilizer on the grid to stop it from that frequency from going out. So you need to get the buy-in from the TSO or the DSO, whoever's managing the grid infrastructure, and then the houses have to be on the same part of that infrastructure. So you can't just trade with someone 10 miles away if you're not on the same network or on the same cluster, if you want. So the hardest part of it all would be getting the DSO to buy in, and then once you do that, everything else should be reasonably easy. And then, so sorry, to answer your question, we don't want to go back to the occupants saying you could have made 100, 200 quid or whatever it might have been, but it's the ESB, it's the local, they're the ones stopping you. They'll be, yeah. So we just want to test to see, is it even what people, would they make much money or would it optimize it? And then if it's worthwhile, then we'll pitch it to the DSO first before the occupants. Yeah.
Good strategy.
Yeah.
Thank you.
Okay, thank you.
So now we go to the last presentation from Tristan. Okay, you can go.
Thank you. Hello, everyone. Last but not least, it's done. But maybe I will start with a short video, and then maybe you awake.
Open door, radio on.
Play radio.
Lights,
Lights on.
protein check.
Temperature check. Loading New York. Set speed.
4.
4.
6.
6.
16.
16.
4.
16. 4. That's down.
So I think this is a building we don't want. It's a very, very smart building. It's advertised from Rima 1000. It's from Denmark, a discounter. And we saw this guy tried to do his life easier with very, very smart building and to optimize everything. But, well, it's shown sometimes it's better to take it easier. But as well, we are here in the session Smart Buildings, Smart Homes. And the European Union, they figured out this as well out that smart buildings are maybe the future. And they developed the Smart Readiness Indicator. There, the question, are you familiar with the Smart Readiness Indicator? If not, I will do a very, very short, brief basic. That's the Smart Readiness Indicator is like an indicator which says how smart the building is. In the basic, it's a percentage, and you have 20%, 30%, 40% smartness of your building, and it's divided in 9 domains, and which are very, very connected to energy. So you can see heating, domestic hot water, cooling, ventilation, lightnings, electricity in general, electrical vehicles, the dynamic envelopes, and monitoring control. So you can see all these domains are connected with kind of energy. And this Smart Readiness Indicator, I'm working a lot with this methodology. And in general, you think when this guy, we imagine this guy said, I want to be 100%, my building has to get 100% of the Smart Readiness Indicator. So imagine you have this percentage. What you could do next? Because it's only then the state of the art, but afterwards, what should you do? And this is a question I try to answer, and I tried to answer this with the thought of who's acting with a building. In general, there are different stakeholders. You have the owner, you have facility manager, you have an investor. When you think of big buildings, you have, for example, when you look at the universities, like they have their property manager and everything, like different people and companies are interacting with the building, and they all have different aims, and they try to get the best out of a smart building, a digital building. And this is, well, I'm thinking what we did with the project. Well, maybe you know some of these companies. We did like a collaboration with like several big companies which are connected with the building. So, for example, the facility managers, you can see as well real estate companies which have a very, very large portfolio. And we are talking with them and try to figure out, okay, you have the smart readiness indicator, and what do you want to do with this and to do an interaction? And this is what we are doing with this project. We have these different stakeholders. The owner, like you can say, it's like 4 main stakeholders: the owners, maybe the users, of course, the hardware provider. We heard it before, like as well, like the companies who are producing the hardware and want to sell them. They, of course, they have benefit of the smart readiness indicator, and as well the facility manager who are acting with the building, and they all hope if they got a smart building, the life is getting easier for them. And we think of the man in the video. He thought this as well. He thought, well, it could be easier if my building is smarter. And every company has their own, aim for smart building. And you can see here to the what we are developed. I think this slide shows. It's one slide, but it's a lot of work behind this slide, because each part, it's every weekend, and I had to work a lot. But I will go very short in some of them. We have in the center what we produced, or what we developed, is like a platform where you can put in the smart readiness indicator, so you get the percentage afterwards. Because till now there's an Excel sheet, but I think the Excel sheet, it's okay for the beginning, but for the future, it's Excel, and there are some problems with it. And of course, these are very the big ones, and maybe some of these are still under developing, and I will show you very few. So a question, what we figured out with the stakeholders, that these domains are very related to the energy. We figured out with them that are missing some parts. So we did new domains, figure out new questions to do it like more for their usage. And there we developed several new questions, domains, as well impacts. And yes, here you can see like a very like a screenshot of our platform. And it's very important that you get an overview of all your portfolio. So means, imagine you have 100 university, 100 buildings, and you don't want to have 100 Excel sheets. No, you want to do in a database, so you can coordinate it very, very good, and you can see it everywhere. And if we have organized it very well in a database, then we can do without any further work some benchmarking. So you can see here, it's a little like not real building, but where we've put some data in. You can see you can compare them. You can compare the buildings. You can see here the average. The green one is the average between these two buildings. And then you can see by one graphic where you should put effort in, so where you should start. And it's like you have to work with the smart readiness indicator. We developed like a platform where you can do it very, very good. Furthermore, I think it's unique, maybe well in Europe and probably in the world. We in Karlsruhe, we have 3 buildings. They are the same, and they are twins. You can see here, like that's the single family houses, and that's not normal single family houses. These family houses, there's no one living there because it's a research infrastructure. But these buildings are very, very high, with a very high automation. So you can do everything, really everything what you can imagine. You can switch on the oven. You can start the shower. You can open the blinds. You can open the windows, because there you can do scenarios. And the benefit of these 3 buildings is that the environment is the same, means the weather conditions the same, means that you can do in these 3 buildings experiments, 3 different experiments, where the weather conditions and you do not have an influence. You can imagine that the sun, when the sun is shiny, you're doing a test 2 weeks there, and 2 weeks later, it's a rainy season, or it's 2 weeks it's rainy. So there are some different, influence. And what were we doing there? We try to figure out which influence has a smarter building of energy savings. So we can say, when you put there this technology, we can say that you will save some percentage of energy. That's one part of the buildings. But I think a very, very interesting part you can't see, but now you can see, is that you have, for all these 3 buildings, every heating and domestic hot water energy producing system you can imagine, and they all connected. So you could, for example, in this building, in the first building, it's the heat pump, and you could use this heat pump for all of these, because they all underground and connected. So you can especially test only heat pumps, or like power to heat or gas to heat. Furthermore, you can put in the garage for like a new technology which will maybe be a rise. And yeah, this is a very unique research infrastructure we can work with. And well, if you have ideas as well, we open to collaborate. Yeah, this was a very, very short overview. You can see what we did, what I talked about, like the benchmarking, the portfolio control, the extension, and as well the experiment buildings. And you can see there more. And I don't want to go too in detail inside these parts. And we are still expanding it. We are still in collaboration with these companies, with these stakeholders. They have ideas, we have ideas. And yeah, it's still an ongoing process. And I think we all know that the digital buildings, we heard the last days here that it's an ongoing process, and we will see what happens in the future. And one last thing I want to will share with you, because we started with the guy in the which he was running, and let's see if he is still running or no.
From one classic to another. This is summer 69.
69.
Thank you very much. If you have a question, yeah.
In your project, you assume that it is an objective to have the SRI score as high as possible.
Well, it depends what you are looking for, because because the smart readiness indicator in general, you can say you want to be the highest energy savings, or you could say the well-being for the occupants could be it's the highest. But I think there is the problem for smart technology, and we will figure it out in the future, is smarter technology could be a problem, because if the risk that it doesn't work is still there. So it's a question we will figure out as well with these companies, with these stakeholders, and then we will figure it out in the practice.
Maybe a second question. I think there are basically three methods to assign the SRI, A, B, and C, as far as I remember. And the method C is based on measurement. So do you have experience because where measurements feed a kind of Excel sheet or your version of the system where the measurement gives at the end the grade?
Well, till now, yes, it's like A and B, because you can put it inside, but because C is like the live smart readiness in and I think it's still under construction, and the European Union doesn't know, and maybe as well the smart readiness indicator yesterday was as well the workshop for smart readiness indicator. I think in the future, in the next years, we'll figure out how will the method C will be. It's still no conclusion for this. Any further questions?
I have one. You were mentioning that you are proposing new categories and new impacts for this smart readiness indicator with the objective of making it more comprehensive in taking into account this well-being or the interaction with the stakeholders. So that will be the conclusion from the research, right? You don't have any propositions yet.
It's one conclusion. Yes, there are more, but there's one conclusion. So to expand, to make the smart readiness more completed. Yes.
But you have some hypotheses that you are testing, or after the research you will propose those new categories?
Well, we are in contact with the working group as well from the European Union, and we are discussing still. And they are very pleased that we got these ideas, give them the ideas, and of course we are. In what I said, we can as well. We will compare the European smart readiness indicator and the KIT smart readiness indicator, which has more, and we will compare it, and then we'll do some research.
Okay. Are there any other questions here in the room? Online, I don't see any questions.
Okay. Thank you.
Okay, thank you very much. So this was the last presentation of this paper session. Not sure if you have any questions for any of the previous speakers. Otherwise, we can close the session here, and you can have a 10-15 minutes break before the closing ceremony that will be happening in the big room, in the big plenary room. And hope you enjoyed the conference and the sessions, and hope to see you all very soon. Thank you. Okay.
Okay, so
Possible just to see the slides of the last presentation quickly, just 30 seconds. Just
yes, use around that.
I'll jump to the beginning and then
work here.
this was the video.
Yes, okay. Okay, great. Research partners, this is a project for research setup. Okay. Overview is very close by answer to the okay. Yes. We want to send this on. In the fourth work, I'll discuss it with this slide. Okay. Portfolio control, okay. Benchmark. Can you go back?
Yes.
Let's go to your okay.
Yeah.
Okay.
Yeah.
All right. Okay. Thank you very much.
No problem.
Right, yeah. So, yeah. Yeah, that's good. We all got feedback.